Rational numbers. Numbers which can be written in the form of p over q, in the fraction form, where p, q are integers but q is not equal to 0. In set builder notation, if we give this set a name q and try to write this as x, a general placeholder for rational numbers, where x is of the form p over q, where p and q belong to I in integers and q is not equal to 0. So this is a mathematical way of writing rational numbers. Let's see which numbers we know of or can be written in this form. Let's start from integers. So integers, and integers are of course positive integers as well as negative integers. All the negative integers, let's say typically -3. Yes, -3 can be written in the fraction form because there is always a divisor 1. So this would be -3 divided by 1. You can also write it as 3 over -1, or you can write it as -3 over 1. In either way, if we take a look here, what is p? P is equal to -3 and q is equal to 1. And if we take a look on this one, what is p equal to 3 and q is equal to -1. So p is equal to, wherever you want to put this, but -3 over 1. Q is equal to 1. So all the negative integers can be written in the form p over q. So they are all negative integers are rational numbers. So positive integers. Positive integers clearly are rational numbers because if we have, let's say 0 is equal to 0 over 1. So comparing it with p over q, here what is p here is equal to the numerator, that's 0, and q is equal to 1, which is the denominator, and q is not equal to 0. That condition is also satisfied. So therefore all the positive integers, all the negative integers, they are all rational numbers because all of them can be written in the form p over q, and that denominator doesn't have 0. Now let's take at fractions. So all the fractions come in 3 different forms. Either they are mixed fractions, either they are improper fractions, or proper fractions. Well, if a given fraction is a proper fraction like 5 over 7, well, proper fraction means fraction which has numerator smaller than the denominator. So this is already in the form p over q because here p is equal to what? 5 and q is equal to what? 7, and q is not equal to 0. So improper fraction, that doesn't, okay, improper fraction is the is the fraction in which the numerator is greater than the denominator. So let's say 11 over 7. So again here the numerator 11 is an integer and the denominator, which is 7, that is also integer, and the denominator doesn't have 0. So we can say definitely that this is a rational number, and mixed fractions are 2 whole 3 over 5, let's say. We can definitely convert it into a proper or improper fraction. Here we can certainly, if we want to convert it, we need to multiply this with this and then add this one here. So 2 times 5 is equal to 10. 10 plus 3 is equal to 13. So this is 13 over 5. And compare it with what is P in this case. P is 13. What is Q? Q is again 5. And Q is not equal to 0. So clearly we can see that all the fractions, whether they are proper fractions, whether they are improper fractions, whether they are mixed fraction, they can be written in the form P over Q. So all the fractions are rational numbers. So far we have established the fact that all the integers, positive, negative integers, including 0, are all rational numbers. Fractions, whether they are proper fractions, improper fractions, or mixed fraction, they are all rational numbers. And now we are going to take a look on the decimals. So decimals. The decimals come in 2 or 3 different ways, or 3 different forms. One is repeating and the one is terminating. Alright, let's say we say terminating decimals. Terminating decimals. So which one? Those who terminate after fixed number of digits, like 2.34. So clearly, if we want to convert it into a fraction, we know how we do it. This will be 2 and 3, 4, and instead of this decimal, we write down 1. And there are 2 digits after decimal, so we place 2 zeros. So the answer is 234, and there we go. This is in the form P over Q. Even we can reduce this fraction to the lowest form, but even if we don't reduce it, still P, the numerator, is 234, which is an integer, and the denominator, which is 100, that is Q. And the denominator doesn't have 0. So it means all the terminating decimals can be written in the form P over Q, and therefore are all rational numbers. So terminating decimals are all rational numbers. Okay, let's take a look on another class of decimals, which are called recurring decimals. Recurring decimals. Let's first try to understand what are recurring decimals. If you ever have divided 10 with 3, if you divide 10 with 3, the answer is 3.3333, and it continues, goes on and on and on. So we can write this as 3.33 3, and the repeating part, we just place a little bar on the top of that repeating part, and this way we denote that this 3 is repeating. Similarly, if we have another number, let's say 0.67, and this time the bar is on the top of the group 67, this will mean that we are going to repeat 0.67676767 and so on and so on. So this time a group is repeating. So these are all called recurring decimals. Now the question is that can these recurring decimals be represented in the form P over Q? That is the question, and we are going to take a look on, let's say, the first number, 3 over, okay. Question is, can 3.3 recurring decimal, can 3.3 bar be represented in the form P over Q, where PQ are integers and Q should not be equal to 0. Let's take a look. Let's name this. We always, if we want to prove that recurring decimal can be written in a fraction, we can name that number. Let's name it as x. X is equal to 3.3 bar, and if there is a one decimal that's repeating itself, then we should multiply both sides by 10. If there is a group of 2 digits which is repeating itself, then we should multiply it with 100, and if there is a group of 3 digits which is repeating itself, then we multiply it with 1000. But in this case, let's multiply it with 10x, 10 on both sides, so this would be 10. X is equal to 3.333 and so on, and then multiply it with 10. So what is the effect? What is the effect of multiplication of 10 on the right hand side? This would be, this point will move one decimal toward right, so this will become 33.333 and so on. So let's this is 10x, so I missed x here. Anyways, so this is 10x is equal to, if we write 30 plus 3.333 and so on, we always want to reproduce the same number which we started with. So this is 10x is equal to 30 plus 3.3 bar. Again, this is equal to 30 plus x again, and moving x on the left hand side, or we subtract x on both sides. So this will give us 9x equal to 30, and 9x equal to 30 gives us x equal to 30 over 9. If we want to bring this into lowest form, we can divide this numerator by 3 and the denominator by 3 as well, which will give us 10 over 3. So there you go. And repeating decimal that we started with 3.3 bar, that can be written in the form p over q, because this number is equal to 10 over 3. And what is p in this case? P is equal to 10 and q is equal to 3. Let's take another example. This time we are going to is 2.6789 are a rational number. In order to prove that this is a rational number, we have to show that this number can be written in the form of a fraction p over q, but where q is not equal to 0. So we can start again by naming the number, which is equal to x equal to 2.6789. Okay, and 6, 7, 8, 9, 6, 7, 8, 9, and so on. Because this group 6, 7, 8, 9 is repeating and the bar is on the top of all the 4 digits. So those 4 digits are repeating. Like I said before, if there are 4 digits which are repeating, we got to multiply it with 1000. If there are, so this is, for 1 we multiply with 10, for 2 we multiply with 100, for 3 we multiply with 1000, and for 4 we multiply with 10,000. So time x is equal to 10,000 time 2.67896789 and so on. So this would be equal to, how many times this decimal will move? 4 times. 1, 2, 3 and 4. So decimal will move to 4 places toward right. So this would become 2678.6789, 6789 and so on. Like I said before, we want to create the same number which we started with. So if we want to create that number, this would be 2. So this we are going to write 26787, and then the number which is 2.6789 6789 and so on. So we always wanted to create this number out of this number, and the remaining, whatever the remaining is, we just write it here because we want to call this x again. So there we start 10,000 x, and this time this is 10,000 x equal to 26787 plus x, and we subtract x from it, minus x, and then minus x on this side and on this side. This leaves as 9,999. X equal to 26787, and what would be the value of x? X would be equal to 26787 divided by 9999. So of course in the numerator that's an integer, in the denominator we have integer, the denominator is not equal to 0, we can comfortably call it a rational number. So what is P here? P is 26787, and what is Q? Q is 9999, and also Q is not equal to 0, therefore this is a rational number.